Hello guys, I am Ali Jawad and welcome to my YouTube channel. This is lesson number 5 on chapter 14 Light of syllabus Physics 5054 for Cambridge and O-level students. The new viewers are requested to go for lesson number 1 to 4 so they may get the better understanding of the topic which we will be going to discuss today. So for their assistance I am providing the link of the previous lesson over here. So let us start with the lesson. In this lesson, we will go for a new topic on light, that is total internal reflection. It found various applications in our daily life, so we will be looking into applications of total internal reflection as well. Now, before we get into the details of the topic, let us define what critical angle is. Consider this container is filled partially with water, and if a light beam is incident like this, so we know that it bends. The light ray will bend away from the normal. However, if we may increase the angle of incidence shown with the green light, so the angle of refraction will also get changed. So for the first light ray, the angle of incidence is this, and the angle of refraction is this. However, for green light, the angle of incidence increases and the angle of refraction also increases. We can go on and on by increasing the angle of incidence, and we may come to the point where the angle of refraction becomes 90 degree. It means parallel to the surface. Such an angle of incidence at which the angle of refraction has become 90 degree, this angle of incidence is known as critical angle. So we can define critical angle as the angle of incidence at which the angle of refraction is 90. Now, why this critical angle is so important for us? Let us look into a bit detail. This same concept is being shown in the different figures over here. So as you can see, if we are increasing the angle of incidence, the angle of refraction changes and it becomes 90. So what will happen if we may go on increasing the angle of incidence even above than the critical angle? Yes, if we may go on increasing the angle of incidence above the critical angle, you can see in the third image that the total light is reflected in the same medium and it is not emerging out of the medium at this point. So this phenomena is known as total internal reflection, and it is only observed when the angle of incidence is greater than the critical angle, because the critical angle, the angle of refraction is 90 degrees. So even more than this, if the angle of incidence will be, the light will get reflected in the same medium. The angle of incidence and angle of refraction will be switched in the formula of refractive index above the total internal reflection or above the critical angle. So in normal cases, angle of incidence is in the numerator while angle of refraction is in the denominator. However, above the critical angle, the formula gets reversed for refractive index. Now, one more important point to be noticed over here, the water is a denser medium because the molecules of water are closer together as compared to the molecules of air. So, air is a rare medium. So, for total internal reflection, there are two conditions. Light should be traveling from denser medium towards the rare medium. Means the light source should be in the denser medium, and the second is the angle of incidence should be above than the critical angle. These two things combine together to enable total internal reflection. Now for at critical angle, the angle of refraction becomes 90 degree, and because of this, if we may put 90 degree in the formula, we will get another formula for refractive index in the form of critical angle. that refractive index is equal to 1 over sine of angle of critical, means angle of incidence is replaced with a critical angle and sine 90 is equal to 1. So this formula can also be used if the refractive index has to be determined from the value of critical angle. And this formula can be used when the angle of incidence is above than the critical angle. Now let us look into some applications of total internal reflection. As you can see in the image, this is an image of a soldier who is hiding in the bunker made up of sandbags, and he is trying to look above the sandbags by the use of a cylindrical object which is known as periscope. So how he is looking above the bags? In his cylindrical object, there are two reflecting prisms. So the light ray is incoming and the prisms are arranged in such a manner that no light is refracted, all the light is reflected back, just like total internal reflection. So the incoming light ray bounces back at the same angle, and because of this it went downward. And there is another prism which is near the eye, and it again causes a reflection to occur, and this is how the soldier is able to see even without rising above the bags. He can see what is happening in the battlefield. Another important application of total internal reflection is optical fibers. Optical fiber utilizes total internal reflection to transmit the signals of communication. So they have a reflecting surfaces inside it, as you can see in the figure. The signal is generated in the form of light and it is being carried by the total internal reflection to the other end, where the receiver can receive the signal and can decode it to get the communication signal. For this, the angle of incidence should be greater than the critical angle. Otherwise, the light will refract and will be absorbed by the material. And when energy will be absorbed by the material, we will not be able to transmit complete light. And when we will not be able to transmit complete light, the signal will be lost. The signal will be lost in that case. So the efficient use of optical fiber is when we try to transmit the signal in the form of light, and the light should be incident more than the critical angle, so that the total internal reflection can take place. Let us look into the advantages of optical fiber. It carries the communication signal approximately to the speed of light, and that is why it is the fastest way of communication. Fiber optics cable can carry signal much faster than copper cables because copper wires have their own resistance. Optical fiber light and flexible, so they are easy to transport and handle as well. And fiber is immune to the water and weather conditions. So just like the metal and metals, they get not get corroded because of moisture and alkaline soil or acidic soil. So these are some of the advantages of optical fiber. So in today's lesson, we have discussed what the definition of critical angle is, and we have also looked into total internal reflection and its formula, and has also discussed two examples of the application. I hope that you would have liked the lesson. Don't forget to subscribe our channel to watch the latest videos on the same topic. Thank you for watching.